Hello, today we're gonna talk about impedance. Compared with the Ohm law, impedance is a ratio of V over I in when V and I is in the vector format and symbolized by letter Z. Okay, first, if we want to find the impedance in inductor, okay, we're gonna draw the AC circuit of impedance. Okay, the Vt of the impedance equation is A sine omega t, or equal A with the angle of 0 degree in the vector format, and It of the impedance equation is A over omega L times with sine omega t minus pi over 2 equal A over omega L with the angle minus 90 degree. And then so we get the impedance of inductor is A with the angle 0 degree over A over omega L with the angle minus 90 degree equal omega L with the angle 90 degree, or equal J omega L. So that is the impedance of inductor. And to find the impedance in capacitor, we're gonna draw the AC circuit. Of C. So first, the Vt of this capacitor equation is A sine omega t equal A with the angle 0 degree, and I of the capacitor is A omega c times with sine omega t plus pi over 2, or equal A omega c with the angle 90 degree. And that's the impedance of capacitor is V over I, or A the angle 0 degree divided by A omega c the angle 90 degree, or equal 1 over omega c is the angle 90 degree, or equal 1 over J omega c. So the impedance of the resistor forms Ohm's law, V equal IR, and the impedance is V over I equals R. So To conclusion, the impedance of inductor is equal j omega L, and the impedance of capacitor is 1 over j omega C, and the impedance of R is equal R. So that's it. This is the impedance of the three components.
So let's begin with admittance. Recall that the impedance Z of a circuit is the ratio of the phasor voltage V to the phasor current I, measured in ohm. We can represent impedance Z is equal to V over I. Now the admittance Y is the reciprocal of impedance 1 over Z, measured in Siemens or big S. Admittance Y is equal to 1 over Z or equal to I over V. So for the resistor, admittance will equal to 1 over R, and for the inductor, admittance will equal to 1 over j omega L, and for the conductor, admittance will equal to j omega C. And we can represent these three into the complex quantity, that is y equal to g plus jb. G will represent as conductance and B will represent as susceptance. And now I will show the example of parallel RLC circuit. And now we have R, C and L parallel with each other in the circuit. We want to find the total admittance in the circuit. Total admittance will equal to sum of each admittance R, C and L for the parallel circuit. And we can say that if in the case of impedance we need to use 1 over R plus 1 over C plus 1 over L to finding total impedance. But for the total admittance, we will find the reverse of them, so we only use the sum of R, C and L. So in the equation we will use total Y equal to YR plus YC plus YL, and Y is stand for admittance. The admittance of R is 1 over R. The admittance of capacitor is j omega C, and the admittance of inductor is equal to 1 over j omega L. And we need to bring j together to see the complex quantity of it, and we will see that, so we can see that 1 over R will equal to G, that is conductance, and omega C minus 1 over omega L will stand for B, that is substance. So that is all the solution of how to find the total admittance in RLC circuit that parallel each other.